In this question, we have a crane that is busy lifting a pile of bricks at a constant speed. They tell us that when the pallet is at a height of 17.2 meters, one of the bricks is going to fall off and then hit the ground after 2.7 seconds. Now, we need to have a little chat about something quickly. Let's say this is the pallet with the little bricks, so the pink blocks are the bricks. Let's just say these are bricks. And this is the crane. And let's say we are going upwards at 5 meters per second. Guys, something that is very important and something that I have noticed some students do get confused with is what the velocity of this brick will be when it falls off. So let's say that brick falls off. What a lot of students do is they say that the brick is just going to go like this. So the brick is just going to start at a velocity of 0 and then it's just going to fall straight to the ground. But in real life, this is actually not what happens. What happens is that you need to understand that this brick is also moving at 5 meters per second because it was moving on the pallet. So when the brick falls, it will go up a little bit. You might not see that with your eyes in real life because it happens so fast. But what does actually happen is that the brick will go up a little bit because it was going upwards at 5 meters per second. Then it will reach a 0 velocity and then it will turn around and go down. So please remember this, guys. When something falls off of an object, it'll always have the same initial velocity as the object. The only reason you don't see that in real life is because it happens very quickly. Or because the object that was already moving was going very slowly, so you don't see it. So the first question here says, why does the falling brick go up before it goes down? You could say a couple of different things. You could say the brick has inertia. Remember inertia from grade 11? Inertia is the tendency of a mass to keep moving in its original direction. The other thing you could have said was that the brick has an upwards velocity. Okay, any of those would be fine. It's only for 1 mark, so you would only need to choose one of those. 4.2, define the term freefall. Guys, if a person jumps out of an aeroplane, are they in freefall? Well, some of you would have said yes, some of you would have said no. The answer is no, because there is gravity, but there's also air resistance. Okay, but if we are looking in grade 12 physics, most of the time we are going to ignore air resistance. So if you have something that is falling, like a brick for example, what forces are acting on that object? Would you agree with me that the only forces when something is falling is gravity? So the definition of freefall is movement of an object under the influence of gravity only. So it is the movement of an object under the influence of gravity only. There's no air resistance, no applied forces, nothing like that. That is what freefall is. Question 4.3. How long does it take the brick to reach its maximum height? Now, before you start using your equations of motion, please realize it's only for 1 mark. So how long does it take for the brick to reach its maximum height? Well, if we look at this graph that they've given us, we can sort of see what happened. The brick went up a little bit, like we said, and then it reaches its maximum height, and then it falls down to the ground. So the time to reach its maximum height would be read off over here, and so it'll be 0.7 seconds. 0.7 seconds, like that. 4.4.1. Calculate the velocity which with the pile of bricks was lifted by the crane. Okay, so that's for 4 marks. So that's something a bit more involved. So we've got these equations of motion down here, and they want to know, calculate the velocity that the pile of bricks was being lifted. So pretty much, what was the initial velocity of the brick as soon as it started to fall? So we could simply use this equation, V final equals to V initial plus A delta T. I'm using this one. And we could say that upwards is positive. Now, I'm only looking at the motion from when the brick was released until it reaches its maximum height. Remember, we said that it does reach a maximum height, as we can see on this graph. So when it does reach its maximum height, what was the velocity? Well, when an object reaches a maximum height, it has a velocity of 0. The initial velocity, when it leaves the pallet, we don't know what that is. So we say VI. Acceleration is going to be negative 9.8 because we chose up as positive, but acceleration is always acting downwards. And then the time to reach the maximum height, we already know that that is 0.7. Then if we had to go calculate the initial velocity, we will get 6.86 meters per second. And because we got a positive answer and we chose up as positive, you can say up. 4.4.2, calculate the velocity that the falling brick hits the ground. Okay, so I'm going to use that formula again. And guys, there are multiple ways that you can do this question. So please do not think that only my way is correct. There are many, many ways that you can do these questions. But I'm going to use that formula again. I'm going to choose upwards as positive. Now, I do know that a lot of students, they would want to start over here maybe. So they'll first get the time, or they'll first get they'll want to know, they'll maybe start from here and then go to the bottom. That's not wrong at all. But what I'm going to do is I'm just going to take it from the very beginning again, when the brick just releases. So we can say that the final velocity, which we now don't know, because now I'm going all the way from here to here. So I don't know the final velocity, but I know the initial velocity I've just worked out, which would be 6.86. Gravity will be negative because I'm choosing upwards as positive. And then the time from the beginning to the end is the 2.7 seconds. And if you had to work this out, we should get a negative answer, or we will get a negative answer. Yes, we do, negative 19.6. So what this means is that the final velocity of the brick is 19.6 meters per second down, because we chose up as positive and we got a negative answer. If you are a student who started over here instead, then your initial velocity would be 0, but the time that you use would be from here to here, so it would only be 2 seconds. Okay, but you would get the same answer. Now, there might be some of you that are saying, Kevin, what is going on? How can the final velocity in this one be 0, but now the final velocity is 19.6? Guys, it all depends on where you are using your formula. For this question, I was only using the formula from here to here, and that's why my time is only 0.7. But then when I did this equation, I'm going from here to here, and now my time is 2.7. So you can have different final velocities and different initial velocities depending on where you are using the equation. 4.5, sketch. Ooh, everyone loves sketching graphs. That was sarcasm. I know that you guys find these sketches a bit tricky. That's normal. I've seen that with many students. Sketch the velocity time graph for the motion of the brick from the moment that it falls until it hits the ground. Indicate all the time values and velocities. Right, so we're going to draw a velocity time graph. So a velocity time graph looks like this, where your y-axis is velocity. And just remember to give the units, which is in meters per second, and then time in seconds. Now, there are two ways you could do this. You could either choose upwards as positive, or you can choose downwards as positive. And that is going to affect your shape of your graph. The one's going to probably do something like this, and the other one's going to do something like that. So I'm going to choose upwards as positive. So at time 0, what is the velocity of the bricks? Remember, the bricks were moving, at the time when it was dropped, they were moving at 6.86. Now, they were going up, and I chose up as positive. That means I'm going to put a positive y value over here, and so we're going to say 6.86. Then what happens is the velocity when it reaches the maximum height would be 0. So a 0 velocity would be here, and that took 0.7 seconds. So I can say 0.7 seconds over there. Then at 2.7 seconds, it hits the ground, traveling at 19.6, but it was going downwards, and so it's going to be on the negative y-axis, negative 19.6. And so that would be after 2.7 seconds, which would probably be over here. And then another time I see that they're showing us is the 1.4. So the way that it works is, if you look carefully, it starts here at 6.86 meters per second. It goes up, reaches a velocity of 0, and then comes down again. So because these two sides, this side and this side, are perfectly symmetrical, they are the same on both sides, it means that the velocity at that point will be 6.86 as well, but it will just be going downwards. Okay, that's the way it works. So at 1.4 seconds, which would be about here, I shouldn't put a dot there, the velocity should be negative 6.86, like that. And so there we can put a little dot, and then we can simply connect the dots. And that's what it would look like. Now, if you chose downwards as positive, your graph would be the other way around. So it would look something like that. Okay. Question 4.6. When the brick lands on the ground, it is in contact with the ground for 0.3 seconds, and then it bounces upwards at 4.59. Okay, so let me illustrate that to you guys. That brick is eventually going to hit the ground. Right? It's going to hit the ground with a velocity of 19.6. We calculated that earlier. It then stays in contact with the ground for 0.3 seconds. You know, if you bounce something on the ground, it will stay in contact with the ground for a little bit. They then tell us that it bounces up at 4.59 meters per second. So that's what's happening here, and the time during that little piece is 0.3 seconds. For 6 marks, calculate the distance between the pallet and the brick when the brick is at its maximum height after the first bounce. Guys, I need you to perhaps pause the video now and read question 4.6 as many times as you need to until you have a 95% idea of what they are talking about. Because if you are confused right now and you watch me, it's not going to help. So pause the video, read it a few times, and make sure that you fully understand what they are talking about. Now, before we start with that calculation, I need to make sure that you guys are feeling very comfortable with what's happening here. So, in situation 1, I'm going to say that the pallet is over here. And then we've got the bricks. And this pallet is going upwards. And what has happened is that the other brick that has fallen off, that was over here, has hit the ground. It's hit the ground over here. And we know that it hit the ground at 19.6 meters per second. And it bounces up at 4.59 meters per second. And we know that this delta t is 0.3. That brick is then going to keep rising, they tell us. Now in situation 2, or let's rather say after some time, this brick has now reached its final velocity after the first bounce, so it would have a v final of 0. And of course that has taken a little bit of time. and it also took a bit of time. Well, how long did it take for the brick to hit the ground in the first place? Can you guys remember? If we look on the graph, it took 2.7 seconds. Okay, so what we need to realize is that while everything was happening, this pallet was constantly moving upwards at a constant velocity. So it's been moving upwards for how long? Well, we need to try to figure this out. It's been moving upwards while the brick was falling down, and that took 2.7 seconds. It was also moving upwards when the brick was in contact with the ground, and it was also moving upwards when the brick was moving up to its maximum height after the first bounce. So we would need to know what all of these times added together would give us, so that we can see how long the pallet has been going upwards for. So what we can do is let's work out this time over here. Now that's very easy to do. We just use the formula Vf equals to V initial plus A delta t, and we're going to choose upwards as positive. And we're just looking at this little piece over here. So we know that the final velocity for this little piece is 0. The initial velocity when it leaves the ground, because remember we're only talking about this little piece, is 4.59. Gravity will be negative 9.8 because we chose up as positive, and then we can work out the time just for that little piece over there. If you had to work out that delta t, I'm not going to round off because it's not our final answer. I'll keep the first 4 decimals, and that's going to be 0.4683 seconds. That is how long the brick takes to rise for its first bounce. So then, how long has the pallet been moving for? Well, it's been moving for, so we say delta t, that the pallet, or for the pallet, will be this time, plus the time that the brick was in contact with the ground, plus the time that the brick takes to move upwards again to its maximum height. And if we had to work this out, we get 3.4683 seconds. That is how long the pallet has been moving upwards for. Can you guys remember what the original velocity of the pallet was? Well, it was the same as the velocity of this brick before it fell. Now, if we look here, we can remember that it was 6.86 meters per second. So that pallet has been moving upwards for 6.86 meters per second for 3.4683 seconds. So we could easily calculate the distance that the pallet has moved. If you realize that it's moving at a constant velocity, did you know that you can use the normal distance is equal to speed multiplied by time? If that freaks you out and you're like, no, I do not remember using those types of formulas, that was like in grade 9 and 10, then you guys can definitely use your equations of motion. So you could say that delta x is equal to vi delta t plus a half a delta t squared. And this is for the pallet. Let's choose upwards as positive. So delta x for the pallet will be its initial velocity, which was 6.86 times by the time, which is 3.4683, plus a half. Now the acceleration, this is the important part. The pallet is moving at a constant speed, so it does not have an acceleration. So this becomes a 0, and the time is 3.4683 squared. Now what's important is that this part here cancels out because it's 0. So what we end up with is that the displacement is this part here, which is your velocity multiplied by time, and that's what we said here. Speed multiplied by time. Yes, speed and velocity are sometimes different, but in a single straight line like this, they are the same. And so the distance or the displacement that we are going to move for the pallet will be still not the final answer, so we'll say 23.7925 meters. But that is how far it has moved from the moment that the brick was released. But if we look at the original question, the pallet was already 17.2 meters above the ground. So now we can work out how high above the ground the pallet will be. So we can say here, pallet above ground will be the 23.7925 meters that it's moved upwards since the brick fell, plus the 17.2 meters that it already had, and that gives us 40.9925 meters. So that is how high the pallet is above the ground. What we now need to do is we need to work out how high is the brick above the ground. Well, it's very easy. What we do is we analyze this area here and we see how high up the brick went. We know that the brick was in the air for 0.4683 seconds. We know that it left the ground at 4.59 meters per second, and so we can simply use this formula over here. I'm going to choose upwards as positive, and so we can see that the distance it went up, so the initial velocity is 4.59. The time that it was in the air for that little piece is that. Gravity is negative 9.8 because we chose upwards as positive. It's not moving at a constant velocity, so it does have an acceleration. And then the time, once again, 0.4683 squared. Please remember the squared. A lot of students forget that. And to 4 decimal places, because it's not our final answer, it'll be 1.0749 meters. So that is this distance. That is how high above the ground the brick has gone. So we can now say that the brick above ground is 1.0479 meters. And so to work out the distance between the brick and the pallet, we can then say, that the distance between will be equal to 40.9925 minus 1.0479, and that gives us a final answer of 39.94 meters. Wow, what a long question, hey guys. So I hope that that made sense for you. If not, please promise me that you will redo it again and again and again until you understand it, so that when you get to your exam and they ask you something like that, you absolutely dominate that question. Okay, it can't get more difficult than that, so please make sure that you understand this. We're now going to move into the last question, 4.7. Calculate the impulse on the brick during the bounce. Take the mass of the brick as 1.9. So guys, during the bounce is only this part over here. It does not include the time that the brick moves up. The bounce is only when it's actually bouncing and touching the ground. Okay? Now we know that impulse is this part over here. That is impulse. So what we can see then is that impulse is equal to change in momentum. And change in momentum is also given to us on the formula sheet as mvf minus mvi. So we can then say that Fnet delta t is equal to mvf minus mvi. Choose a direction. I'm going to choose upwards as positive. And so this whole thing is impulse, so you can just write it like that. You don't have to go fill everything in. Some students might go fill in the time, although we have got that. You don't want to do it that way because this whole thing is called impulse. If you were only trying to calculate the net force, then you would maybe do that. Okay, and so the mass of the brick is 1.9. Its final velocity after the bounce is 4.59. Now, here's where you need to be careful. Obviously the mass is 1.9, but the initial velocity is 19.6, but it's going down, and we chose up as positive. That's where students make the mistake. So just be careful over there, guys. And so I'm going to go add all this together now, or multiply, and you should get 45.96. Now the unit of impulse is Newton's second, and then we chose up as positive, and we got a positive answer, so that'll be up.